Merrifield solid phase peptide synthesis. This polypeptide synthesis method we are going to discuss in this video, which is somehow looking complicated but not so much complicated. If you watch this video carefully, you will be able to write all these structures so easily. So let us start with the synthesis. So first of all, I want to say that the Merrifield is the name of the scientist, who is R. Bruce Merrifield, who got the Nobel Prize in 1984 for this synthesis. Now, why it is called solid phase? Because in this synthesis, you just look at this corner of this board. This is a polymer which is insoluble, water insoluble polymer, which is actually a polymer of styrene, which is, you can call it as a polystyrene polymer, where this group is there, chloromethyl group is there, CH2Cl group is attached to the benzene ring. So this is the site where the reaction is taking place. So because of this solid polymer, we call it as a solid phase peptide synthesis, and we can synthesize a big molecule of polypeptide, a larger molecule of polypeptide with much more purity. Now see, you watch this video very carefully. I will explain it step by step. For this, at the beginning, for this synthesis, we need one reagent. You look at this reagent carefully, forget all other reactions written over here. This is called 9-fluoronyl methyl chloroformate. 9, this is 9 position methyl chloroformate. So this is 9-fluoronyl methyl chloroformate. This reagent is actually abbreviated as Fmoc-Cl, because every time you need not to draw the structure, this is somehow complicated. So instead of that, because this Cl is important of this reagent, so we can use this abbreviation Fmoc-Cl, but this is actually 9-fluoronyl methyl chloroformate. Now, you have to prepare first, you have to protect actually the amino group of, NH2 group, amino group of amino acid by using this 9-fluoronyl methyl chloroformate. Now the reaction is taking place, Cl and H of amino group to form HCl. That means these two groups you have to join together by using sodium carbonate. And you can see here CH2OCO. This linkage is formed. Actually, the free amino group is now protected by using this Fmoc-Cl group, by using this group. And you have to prepare this separately. Now the same, this protected amino acid can be written as like this, because you need not to draw the structure of this portion of this molecule, which is somehow complicated. Instead of that, you can write FMOC. That means this is called FMOC protected amino acid. So this amino acid is ready for the synthesis now. Now, your column is ready. Your solid phase polymer is ready, which is having free Cl group. Now this amino acid is added on this polymer, where the free Cl group is present in presence of base. You can use base. Now see what will happen. Because of this base, these H you have to remove and this Cl you have to remove. The remaining portion from oxygen you have to join to this polymer. So HCl is produced, and that is neutralized by the base. And you can see here, this whole group is now joined over this polymer here at the oxygen. So Cl of polymer and H of this amino group, which is protected, is removed, and you have to join this to the polymer. Now this polymer is having this amino acid, which is not having free amino group. But for the peptide synthesis, we need a free amino group. So we have to deprotect. Deprotect means you have to remove this FMOC group. This portion you have to remove from this polymer based amino acid. Now for this purpose you are using a amine, or you can use this piperidine to remove this, to deprotect this. And once this is removed, this FMOC part will convert back to this H. There will be H. We are not interested in what will happen there. You simply remember that you are going to remove this portion by using this piperidine, this base. So once it is deprotected, your amino acid is now having free amino group, which is ready for the amide formation, which is ready for the peptide synthesis, which is ready for the synthesis. Now see, now again, whatever amino acid you want to join here, that you have to protect first by using this Fmoc-Cl. This is, you have to perform that reaction separately, and that protected amino acid you are going to add again over this polymer where the amino acid is attached and it has now a free amino group. Now along with this amino acid which you want to join here, you have to add one more reagent, that is called DCC. The structure of DCC I have shown here in this box. This is dicyclohexyl carbodiimide, which is abbreviated as DCC, which is good dehydrating agent, which removes water molecule. Now see, once this another amino acid is added, it is now going to combine with NH2 by using this OH and this H. So you know very well, when OH and H is combined, we get here water molecule, and that water molecule is removed by using DCC. That is dicyclohexyl carbodiimide. Now once we remove that water, this amino acid is now attached to this amino acid on this polymer. So that I have shown here by using this red color. You can see here a peptide linkage is produced between the two amino acid. In fact, a dipeptide is produced here. Now this amino acid is joined to this amino acid by using this peptide linkage, which I have shown by using a red color. Now, you know, this amino acid will go at the terminal where the amino group is not free. So if you want to add another amino acid, you have to free this group. You have to deprotect this group by repeating this step, by using this piperidine, this base. So some steps are skipped due to lack of space. So you use this base which will free this amino acid, this NH amino group, or which will remove this FMOC. And once this is removed by using this, you are going to add DCC again in this step, that is dicyclohexyl carbodiimide, along with the desired amino acid, which should be protected first with 9-fluoronyl methyl chloroformate. So this is again added. So instead of repeating that step, I have written here, firstly you have to add this, secondly you have to add this, and thirdly you have to add your desired amino acid. Now it is having, you assume that the free amino group is there after doing all these steps, and this newly added amino acid again reacting with this OH and H of this free terminal, free amino acid, free amino group. So to get NH2O, again one H2O is removed, which is actually done by using DCC as a dehydrating agent, and another, this second peptide linkage is produced. So second peptide linkage is shown here. The remaining portion you have to join likewisely, which is not so difficult. Now this is, now tripeptide is attached to the polymer. Tripeptide, you can add a few more amino acids and you can grow that chain. In fact, you can produce polypeptide, but at certain point you have to detach that polypeptide chain from the polymer, and that can be done by using HF. But before adding HF, you must free that amino group, otherwise there will be a problem. So first of all, this piperidine is added, this base is added to deprotect the terminal amino group. Then you have to add HF, so that HF will actually acting here on the polymer where the peptide linkage is attached. Now you can see here, this H will go to the oxygen, this bond is broken, you just see here carefully, and H of HF is now going to join this oxygen because we need free carboxy group, and F will go and attach to the CH2 group. So now once this is done, once this is broken, once this is removed from the peptide, I mean polymer, not peptide, so we get this tripeptide molecule or even polypeptide. And you can see here now the polymer, here the polymer instead of Cl, the F is attached. Easily you can remove this polypeptide from the reaction medium, and in this way you can prepare polypeptide, which is very, very pure, because all impurities will be washed out during this process. And nowadays a automated solid phase polypeptide synthesizers are available in the market. By using that synthesizer you can produce a polypeptide molecule of your desired sequence of amino acids. In this way, this is very, very interesting synthesis. Actually we call it as a Merrifield solid phase peptide synthesis. Thank you.